This lesson is on the converse of Pythagoras' theorem. The learning intentions for this lesson are to understand what the converse of Pythagoras' theorem is used for, and to be able to apply the converse of Pythagoras' theorem. So first of all, we're going to have a look at Pythagoras' theorem itself. So Pythagoras' theorem is used to find the lengths of sides in a right angled triangle and will only be useful in a right angled triangle. It doesn't work in any other type of triangle. Remember, the hypotenuse is the length of the longest side, and we always find it directly opposite the right angle. Okay, so Pythagoras' theorem states that in a right angled triangle, the sum of the squares on the shorter two sides is equal to the square of the hypotenuse. That sounds really quite complicated, but if we go ahead and label the sides of the triangle A, B and C, where C is the hypotenuse, which is the longest side, we can just use the formula c squared equals a squared plus b squared. So let's look at an example of how we would use Pythagoras' theorem to find the length of a side. So it's asking us to find the length of the hypotenuse in this right angled triangle. So first of all, we know the two shorter sides, we're going to use our formula c squared equals a squared plus b squared. Now we're going to substitute in the values we know for the shorter sides, which is 3 squared plus 4 squared, because your shorter sides are 3 and 4 metres. Then calculate 3 squared and 4 squared, which are going to be 9 and 16. Add them together, we get c squared equals 25. Now we actually need to find the length of the hypotenuse, so we now need to take the square root to be able to find c. So c is going to be the square root of 25, c equals 5. And that should be c equals 5 metres because the lengths in this picture are in metres. Okay, so let's look at the converse of Pythagoras' theorem. Now this is kind of doing the opposite. This is used to check whether a triangle is right angled when we don't know for sure, but we do know the three side lengths. Okay, so here's an example. Is this triangle right angled? We've got three side lengths, 9, 12 and 15. So first of all, let's look at the hypotenuse. So in Pythagoras' theorem we're dealing with the squares of the sides, so in the converse of Pythagoras' theorem we're also dealing with the squares. So let's look at the hypotenuse squared, which is 15 squared, which is 225. Okay, so now let's look at the sum of the squared shorter sides. So we have 9 squared plus 12 squared, which is 81 plus 144, which gives us 225. So what we notice is that this hypotenuse squared is equal to the sum of the squares on the shorter sides. And because of that, because these values are the same, by the converse of Pythagoras' theorem, we know that that triangle must be right angled. And we would write a statement, as the square of the hypotenuse equals the sum of the squares of the shorter sides, then by the converse of Pythagoras' theorem, the triangle is right angled. Let's look at a second example. Is this triangle here right angled? We've got side lengths 8, 6 and 11. So again, we're going to go through the same procedure. First of all, look at the hypotenuse. If we square the hypotenuse, it's going to be 11 squared, because the hypotenuse is the longest length in the triangle, which is 11 in this case, and 11 squared is 121. Now we're going to look at the shorter side squared. So the sum of the squared shorter sides is going to be 8 squared plus 6 squared, which is 64 plus 36, which equals 100. But notice in this case, the sum of the squares on the shorter sides is 100, the square and the hypotenuse is 121, and they're not equal to each other. So that means that this triangle is not right angled. So we would write a statement, as the square of the hypotenuse does not equal the sum of the squares of the shorter sides, by the converse of Pythagoras' theorem, the triangle is not right angled. I hope you've learned something about the converse of Pythagoras' theorem in this video. Remember, you can always play it back as often as you like to get the hang of these concepts.